All right, so I'm going to walk you through a complete 3D CFD simulation on ANSYS Fluent, starting from the geometry preparation and going all the way through to analyzing the results at the end. And I'm going to be using a rear wing geometry for this. So we're going to start with the first step, which is prepping the geometry. So assuming that you guys did your geometry on SolidWorks, they'll be saved as SolidWorks files, and this may or may not work. But what you can do if it doesn't work, so we'll just drag a geometry tab up here and then right click, go to import geometry, browse, look for whatever geometry you want to sim. So for example, I'll use this rear wing right here. And this right here is a SolidWorks file. And I'm going to set the import facet quality to very fine so that for things like rear wings and airfoils where we want that nice curvature, we want it to be very, very fine. And then I'm going to go ahead and click Edit in Design Modeler, which will open up a new window. Now, sometimes importing a SolidWorks file won't work, in which case you will have to go into SolidWorks, save the file as a step file instead, and import that. It's the exact same thing, just an extra step you might have to do. And it's related to whether your ANSYS is set up to read SolidWorks files or not. But once you get to the Design Modeler, you hit Generate, you should see that your geometry will pop up here in this window, just like that. We can see it's a rear wing, it has 3 elements, we have end plates, and then we have a gurney flap right at the back, right there. So, the first thing we want to do, because this geometry is symmetrical, we only need to simulate half of it. So we're going to create a bounding box, or a body of influence, as it's called, around half of this geometry right here. So that will be our fluid domain. So we're going to head and click on the XY plane, which is the plane that's cutting right across the middle of our part. Click that and then hit New Sketch. And then go into sketching down here, and we're going to sketch a nice big rectangle around it, just like that. And then we're going to dimension it. So this is going to depend on the part you have, the size of the part, and essentially what you want to simulate. But for a generic rear wing, we're going to set these 4 dimensions and then change them down here. So we know L1 is this dimension here, L2 is that one, etc. So L1 is going to be 6 meters, L2 is going to be 12 meters, and both L3 and L4 are going to be 5. So we can see we have created a very, very large box around it. Right now, there's only a 2D sketch though, so what we want to do is extrude this and make it a 3D box. So we hit Extrude up here. Apply, because that's selected our geometry. Instead of add material, we want to go to add frozen. And then our direction vector is going to be normal. And for the depth, we're going to select 5 meters. So what that should do, once we then hit generate, is it creates a box around our part. And as we can see, half of our part has been left out right here. It's not part of the box, and that's because we only want to simulate half of it, and then we can multiply whatever force values we get from the simulation by 2 to simulate what the full wing would be. But because it's symmetrical, it just saves computing hours if you only do half of it. So that's one part of it. But now our box and our part aren't quite intertwined yet. So what we want to do is remove our geometry from this box so that we basically make a rear wing shaped hole inside our body of influence. So the way to do that is if you go to create and then Boolean, and instead of unite, we're going to select subtract. And so the target body is going to be our big box, and the tool bodies are going to be our part 1 or whatever you imported, our rear wing. We can select it from the tree and hit apply. And so now when we generate, you'll see we've only gone down to 1 part. And that's because there is no longer a rear wing in our view window right here. It's actually, if you look and zoom in, it's actually a hole inside, and it's just shaped like the rear wing. And that's exactly what we want to do to simulate the airflow, because now the airflow coming into this box will see all of these as walls, and will therefore simulate as if there was a rear wing inside this fluid domain. So what we want to do, rename our solid firstly. So if we rename it, usually outer BOI is a good name. It's on all the scripts, for example. It just means outer body of influence. And that's because sometimes we're going to have a second inner body of inflows, which I'll show you in a minute, that may make things slightly more complicated. So what I'm going to do is create an inner buoy right now. So we're going to create a new sketch in the same XY plane, sketch another rectangle, this time slightly smaller, like this. Again, we're going to dimension it. 1, 2, 3, and 4. And this dimension is going to be 1.5. This dimension is going to be 6. And then both of these are going to be 1 meter. There we go. And then we're going to extrude this sketch as well. Again, add frozen, don't add material. And instead of 5 meters, we're going to extrude it by 1.5 meters and hit generate. So now we can see we have 2 separate boxes. The first one has a rear wing shaped hole inside of it. The second one does not. This is just a pure box. We're going to rename the second solid inner BOI. There we go. Now, the last thing we have to do in this design modeler is to set our name selections for all of our faces. For example, the inlet, the outlet, the slip walls, the symmetry plane, etc. So you can go ahead and start by clicking on the inlet or wherever we want the airflow coming into. Right click that, go to name selection, and then name it inlet. Hit enter and then hit generate. And you can do this for all the other faces as well. So this is going to be our outlet. Name selection, outlet, generate. Now, we don't need to name any of the inner boxes because that's just the body of influence. We're not using that as a fluid domain. And you can select multiple faces at once by hitting the control key while you're selecting. We're going to name these the slip walls and generate. And finally, this face right here is going to be the symmetry and generate. And we also want to name all of the faces applying to the rear wing itself. But as you can see, we can't actually click them from here. So what we have to do is if we, for example, click inlet here, right click, we can go to hide faces, and that will hide that inlet face. So now we can click things that are inside. And we're going to want to do this for all of these. So if we select them all, hide faces, now it's a much simpler geometry. And again, we don't want to select any of the faces on the inner buoy, so we can just go ahead and hide that as well. And now we just have the rear wing to work with. So we'll start with the first curvature element. I'm going to name that E1 curve, which stands for element 1 curvature. Same for element 2. We're going to go E2 curve. And for element 3, E3 curve. You can also generate by pressing the F5 key. You don't have to go up to the generate button every single time. That's just a quick tool tip. And then we also want to select the flat faces of the end plate. So we'll call these end plate soft, generate. And now we need to get to the very, very small faces that sit at the back of each airfoil and the faces that sit on the edge of the end plate. So to do that, we're going to hide all the faces we just named. Those like that. And we'll start with the trailing edges of element 1 and 2. So remember, control click to select both. Name selection, we're going to call these trails and generate. We can go ahead and hide the trails now. Next, we're going to go to the gurney flap, which is 3 faces. So we'll select all 3. Name selection, call it gurney, and generate, and then hide. And all that we're left with now is the border of the end plate. And we could go through and select all of these by hand, but that would be a pain. So we're just going to switch our selection method up here to box select, and then click and drag to select all of them, and then right click name selection. And we're going to call these end plate props. And there we go, and generate. So now if we bring back all of the faces, you can see show all faces right here, and bring back the body as well. There we go. We have ourselves name selections for all of the outer faces, which are important for setting the fluid domains. We have name selections for all of the rear wing or geometry faces, which is going to be important for selecting forces afterwards, or just setting mesh sizes. And then we also have a second buoy inside, a BOI, buoy for short, which is going to help us refine our mesh in that region. But yeah, so what we're going to do now is we can freely close Design Modeler right here. And it will bring us back to the workbench. And then we're going to want to save this somewhere. It doesn't matter where. I'll save it in just the desktop for now, as CFD tutorial. But what saving does is it creates a directory for all the files you're going to create when you do your simulation. And that's going to be very important, so you actually know where they all are at any given time. So if we go ahead and open up the directory right now on the desktop, and then CFD tutorial, you'll see it's created a CFD tutorial folder. And if we click on that, it'll show us all our session files and all the files that we're going to need for our simulations. And that is it for the geometry prep section of the CFD simulation.